So, if cloud and write. So now assume we would like to go to cloud in Java. This is what I told you in the keynote. I would like to show you with source code I had from yesterday and explain all the things why it is like it is. And your job is to challenge me and say what you are saying is not true. With whatever, it will work far better. It is faster, cheaper, less complicated, or more scalable. So this is the idea. This works the most. So still Adam Bean and still podcasts, and I have the YouTube shorts. They're actually fun, so I enjoy them a lot. If there are some, let's say, boring meetings, right? So I write some shorts, and then after the meeting, submit them, and this is done. This is actually pretty cool. Sometimes my clients are wondering why the camera is off and mic. It's like, yeah, because I'm recording something different, right? I don't have to participate in discussion about whatever, decoupling. Code talks, and this basically was. So you saw the presentation. Now, this is the GitHub account. It is Adam Bean Airhacks. I have just to put my AR glasses on it. They're way too strong, so this is. But I see even the pixels now. This is strange. But so first Quarkus. So I would like to go come here, and BaselOne looks more professional than junk, right? So and first. This is a project I wrote. I've deleted the Git repository, but it's 10 years old. And I started at the Java 1. And if you take a look at the code, it is basically what I show you in a second. Okay, stateless is no more there. I will replace it with request scoped. But basically, is what I will show you right now. So this is resources, and this is roughly 10 years old. It's still my GitHub, so you can take a the first commit was a Java 1, actually. I got the idea. Okay, now, back to today. B1. So what I have, now I have a Quarkus application, which looks almost the same. The only difference is if you search and replace for Java X and replace with Jakarta is the same. So what means is that in my projects we have a a porting strategy, migration strategy from Glassfish, Whitefly, whatever, to direct serverless cloud. So this is the idea, because the code is compatible, which is already pretty interesting. So, nonetheless, people who work with JAX-OS, they like the API. And the question is, why we have to learn something different if you go to the cloud? So what we use, we keep writing the same code I always wrote the last 20 years with different prefix. Instead, Java X, Jakarta, that's the only difference. And it's still working. So it means what I showed you right now, this is a small app, Quarkus, and then we can deploy it to the cloud, the same app. And you can run it on-premise or in the cloud, in serverless. And why serverless? Because I'm not a TikTok, boring enterprise companies, and we can save money, and it's good for the environment. What I skipped in the keynote, because of time, there is an interesting law coming. It's on the horizon in Germany. Lieferketten something Gesetz, LKSDG, I always forget it, it's a very long name. And until April 2024, large companies will have to justify their CO2 consumption. And this is why I got so many questions regarding green, and this is how I found the papers. Because I said, okay, no, what about your CO2 footprint? It's like no idea. And the cool story in the cloud, you get it on the invoice. You will see CO2 footprint on the invoice, problem solved, right? With Kubernetes, you will need additional tools to find out how much each service consumes or not. But yeah. Now, so I have the Quarkus here. Now let's do the following. So first, B1 is bone. So why is bone? So Maven package. What I do, Quarkus is fast or whatever, but it doesn't matter right now. Okay, so unit tests are bad. So this improves already the the CO2 footprint, right? So now, now So this is a decompiler. And what I plan to do is not that simple, because I always forget where it is. It is in Quarkus app. There is a lib, and I think, no, there. Also, boot is wrong app. Bone is good, Quarkus, and this is transferred bytecode. So, and this is what Quarkus does, right? This is the I/O SMORI. And what I forgot to do is I forgot to create a greeter, Java, and it is application scoped and has a method hello, and it returns hey Basel. So, and then I can here inject the greeter, and the injection is important. This is why I need it for my sample. Greeter and hello. So, okay, cool. So now let's redo this. Maven clean package. Open with the window. Target Quarkus app. And there's app. Quarkus was transferred bytecode and generated bytecode. So let's see. BCV. So let's see. This is a generated bytecode. One second. Generated bytecode. Airhex. This looks good. So what happened is at build time, Quarkus found per reflection the injection point, and then he created. Let's see. As you can see, there is a greeter bean and ugly code, ugly like as hell, but very, very fast. And here somewhere, there's arc container, injected bean, this bean. And where I'm going with it, you won't find reflection. What you will find is here a direct injection somewhere. Here, get context, and this injection provider supplier get. This is where the injection happened. A greeting resource greeter is greeting resource greeter. So the entire trick of Quarkus is it searches all the metadata at build time, generates bytecode, eliminates reflection, and optimizes the bytecode for runtime. And I'm lucky because it also is compatible with my programming model, and Micronaut does the same. Quarkus does this with extensions, and Micronaut does that with annotation processors. Okay, now what I showed you, this Maven package generated a bytecode, and now I can start Quarkus very fast with Java -jar target. It was Quarkus app and Quarkus run. So this is now the standard startup time. And it was 300 milliseconds. Let's see, do it again. So it is, 300, always 300 milliseconds. This is what you get, the basic startup time of the microprofile application. It is already dependency injection there, microprofile config is there, JAX-OS is already included. If you add all my stack from Whitefly, I would say, it will be roughly the same. So no impact on the startup time. Questions so far? No questions. Okay. Now, what you can do to improve RAM, you can say Maven package -p native. And now it will translate the code to native code, and this we only do on premise, not on AWS cloud, because we have plenty of memory. We discussed this yesterday, but I would like to show you, this is what I didn't show yesterday, that it is very possible, you can do this. We only do this on Azure for very specific SKUs. If you have a premium SKU on Azure for private networking, you pay for RAM. It is worth. On OpenShift, always do it on premise. You will save a lot of RAM, 80% of RAM. And the startup time is incredible. It's like C. So wait a second. But you see, it takes a long time, so I only have to do it if I really have to, right? Because otherwise, I'm too impatient. So it uses Mandrel behind the scenes. It comes from Red Hat. You get official support. Yeah. It runs on battery. This is the problem. Like, it's incredibly slow. Okay, we will survive. Now, what I have, this is Bone 22 Runner, right? Bone Runner, it's a nice name. So, and this is how it feels like if you do it. So I use it for CLI, whatever. It starts in 0, 0, 16 seconds is the same application without any optimization. So I could package that and ship it as Lambda. I will improve the startup time, but I would not improve the performance because Corretto JVM is still faster. Okay? So this was show you how the possibilities are. And this Quarkus, what I did on purpose, I used the Quarkus CLI without any templates. This is exactly the same experience you get at home if you try the same code. Questions so far?
So you said yesterday Corretto gets continuously patched, and that's nice.
Well, what gets patched?
Corretto.
Yes.
But when you do it like this, you lose that benefit.
Yes. And this is also not serverless, really, because if you think about that, because you now this is actually your responsibility to patch the image. That's the problem. And you have to watch, maybe now even worse. Now we have two companies evolved, right? We have Red Hat with Mandrel and indirectly Oracle. So if there is a problem with the native image, you have to resolve it. So you're right. So this is not pure serverless, absolutely right. So this is why I don't use it a lot. But on-premise is a completely different story. Very good. He was in my workshop and challenged me regularly, which is perfect. Questions? Then go to the cloud, right? If I go to the Bone, let's do the Cloud Bone project. It's a good name. Cloud BaselOne. So let's close everything. So step by step. This is CDK, and behind is Lambda. If we take a look at the Lambda project, there is no difference to the project I did before. Exactly the same code. The same code, no difference. Now, the greeter, this is why I name it exactly the same. It is injected, we have logging, we have config properties, so no difference to before. So what's the difference? The cool story is, what I even can do, Maven Quarkus dev, I can launch the Quarkus locally in dev mode, and also it is a Lambda without any specific environment. It starts, and I should be able to access it localhost 8080, and I think it was hello, and this is hello Quarkus. So this is my Lambda. Now, what happens if I do Maven package? So if I perform Maven package, this is the entire trick. Something happens, and instead of Quarkus run, I get here function.zip. And the function.zip can be directly deployed as a Lambda. Okay, so what we prove right now is exactly the same source code. I can move it, I can run it as jar, as native image, as container, or as Lambda. Now the question is, how this happened, and how I create the infrastructure. And so to show you this, there is the one difference to the prior project is this. There is a extension, is this one, and if the extension is available, Quarkus produces function.zip. If the extension is not available, Quarkus produces Quarkus run. That's the only difference. So I can imagine what we do in real-world projects. We have Maven profile, and we can decide, or we run it 2 times, once for on-premise and once for Lambda. Someone asked me about hybrid architectures. What we can actually also do, we can have a Lambda and Fargate running at the same time with the same code behind one single load balancer. Also works. Questions so far? how it's called, slides don't crash. Now everything can crash, so ask questions, right? So, okay, and 2 transactions per second, entire month, you will pay 15. We can close the door if you like, right? Because they are not listening. They are doing the coffee break. So Tsununi, right? Tsununi is happening outside. Okay, now there are no Tsununi in my workshops. Tsununi-less we are, right? So Cloudbone. So there is a strange script called build and deploy don't ask, because usually I do it for more complex stuff. And what happens here, you see there are 2 mavens, maven clean package and CDK deploy all. So this package packages the Lambda, and this deploys the infrastructure. And everything is Java. So how Java? What happens here? So there is a POM, and you see it's just AWS dependency, which makes sense because I would like to deploy to AWS. And there is CDK app with some unused imports, which will also make sense because what's here? I have here a function URL stack, which is cheap, but you get ugly DNS names. Then you have a Lambda API gateway stack, which is a little bit more complicated, but you can have nice DNS names, you can have SSL certificates, you can have API keys, throttling, version routing, and caching. And you have ALB stack, which is for a high load 80% cheaper than this stack, but for low load you have to pay 40 euros for the ALB and the VPCs. So depending on the performance profile, we pick different front ends. So this is the reason. So the project I have here, this is from my GitHub. You can just clone it, and I use it for all my commercial projects and sometimes on conferences. Actually, I think the first time at conference, usually also some online YouTube videos, but I think the first time live. Okay, so now let's see what happens. We have here a function URL stack, and this is the name of the Lambda, and I would like to rename it to, what was it, Cloudbone, Bone. And so this is just Java code. You see, it just depends on AWS, but Quarkus is what I've written because it's reusable. And what I'm saying here, this is the configuration. I would like to have a half CPU. Okay, I said you 2 gigs. This runs with 1 gig, so it will be 7 euros a month, not 15. And this is some sophisticated. Oh, this is the most important thing here. This is actually the only thing you have to do to deploy Lambda. What I'm saying here, I would like to have Java 17. I don't care which one. Please, AWS, patch it for me. Then I have here architecture, which is ARM or Intel. Then I say where the function comes from. Then the memory, what's the name of the function, and the timeout. And this is basically it. So what happens before, forget it by the amount of Terraform. If you have at home, this is interesting, right? So this is compare Java code with Terraform. So it supports snap start. And this was a little bit harder because we have to add new versions. What snap start is crack in the cloud. With that, we can freeze the deployment and we start the entire thing from memory without booting Quarkus. It halves the startup time. It is available for 1 year right now. November last year it was introduced. So we can pick and choose. Yesterday in a workshop I didn't use that because it starts 3 times slower because it optimizes Quarkus for 3 availability zones. And this is based on the crack coordinate resource at checkpoint. Okay? Questions? Yeah. Yeah, the cloud does not support it yet, 21. But there is a trick. As I started with another project, the Java 17 was not supported. And I really wanted to have Java 17. So what you can do, you can create your own custom runtime. But 17 is good enough. And if you use custom runtime, you lose all the advantages because you have to care about your runtime. But I had a discussion with the Azul system guys, and they claim that Azul is a little bit faster than Corretto. So for high performance, it would be interesting, you know, to try out Azul system. Maybe you can save some more money. But for the most enterprises, who cares whether you pay 13 euros or 12, right? I mean, but on the heavy load, it looks completely different. So in one serverless project, we will probably pay 60,000 euros a month for that, and it's still worth, right? Because of marginal costs. But then it is worth, you know, to play with performance. For usual enterprise project, doesn't matter. And interestingly, in this project, the ALB, we will pay like, I forgot, 1,000 euro, and the HTTP API gateway, 60,000 euros. In usual enterprise project, no difference. Okay, so let's see. Cloudbone, build and deploy. Don't ask. And now it uses the CDK and deploys. This is Node.js warning, and then it deploys because behind the scenes Node.js is working. This is the part of the CDK, and now it deploys the Quarkus in the cloud with function URL. And after, I don't know, 80 seconds, I will get an ugly URI, and I can call the Quarkus with half a CPU with entire microprofile on it. So this was the live demo. So we can see the behavior and how it works. Look at the logs to estimate the costs. That you have the live example, right? So now we have 1 minute time to ask questions because it will take, yeah.
You added an application scope.
Yeah.
What's about all these scopes?
That in AWS, just application scope, you think about this, request scope would be waste of time. And usually what we do, if you have DynamoDB resource or S3, we don't inject it, we just have a static field. Doesn't matter. Because what you learned in the keynote, all the resources are connectionless, use HTTP. So so you can just have static, it doesn't matter, you know, how the connection is dispatched. And so it worked. Usually there's some collision, but it worked. So this is the new function URL, the ugly one. And I have a how to call it, a macro, curl T, which measures performance. And it was hello. And this is the absolute cold start of the entire infrastructure, not only the Quarkus, all the, you know, networking and so forth. And it was 3.5 seconds the first time. Now it is already initialized, and there are the subsequent calls, half a CPU. You see the entire round trip to Frankfurt and back costs 150 seconds. An entire monolithic microservice application with microprofile, which looks like my 10 years old Glassfish project. That's the deal. No reactive programming, no strange things, you know, old code. Questions? What's wrong? No questions in the keynote, no questions in the... Are Swiss people shy? Oh, okay. So this is the log files. And you see, and this is initialization. I will pay build duration 500 milliseconds. We have 1 gigabyte of RAM, and Quarkus use 180 megs of RAM. So if you run 2 gigs of RAM, it is way more than we can consume. This is why GraalVM does not make any sense. And why I use 2 gigs of RAM? Because to have 1 CPU. Why? Because 1 CPU is the break even. For unknown reasons, Java starts with 1 CPU significantly faster than with 1/10 of a CPU. So I mean, how to describe it? You can run Quarkus. I could launch Quarkus with 256 megs of RAM. Okay, but then it will, in relation, start significantly slower. So I will pay more than with 2 gigs. You know what I mean? Because Java with 10th of a CPU is 20 times slower than Java with 1 CPU. So you can imagine that. So what I found out is that 1 CPU is the best choice. So we always go with 1.8, 2 gigs, because it is the fastest solution for normal workloads and the cheapest. So less than that is not worth. You will pay more with really bad performance.
Every request gets its own instance.
Yes.
Why would we care about virtual practices?
That. This is they were not on the slides in the cloud. So on the premise, virtual thread, because there's one instance, right? And you can have lots of cores and run everything on the monolith. In the cloud, no virtual threads. Very good. You see, the architecture is completely opposite, right? If you think about this. So you cannot just, it is suboptimal to pick something you did on premise and push it to the cloud. Okay, you see that the build duration for the calls, this is yet the call right now, is 5 milliseconds. The calculation was 100. So you see a Quarkus with entire microprofile completes the call in 5 milliseconds with dependency injection to greeter, config property, and log, system out println. That's Java. Okay? What this means is, with your enterprise knowledge, combination with Maven and this, you are, you know, the, how to call it, how it's called, times 10 cloud native developer. Actually, with Node.js and Python, they cannot compete with us if you do it correctly, if you think about this. Okay? So if I'm in a company, no one believes me. It's impossible. Lambda, I cannot play with functions. And now, who said this? You said this per CPU. Now imagine the difference, right? If you have, I have to bash on Kubernetes because it's fun. So it is the largest, so I can say it, right? So if you have a pod with 4 CPUs, you have a pod with 4 CPUs, and you're scaling with threads. I have a Quarkus with a half CPU, but if I start 1,000 requests, 500 CPUs will work for me. And I have 1 gig, so I get 1,000 gigs RAM. It scales linearly, without no load balance and nothing. And yesterday they asked me, what's about serverless? For me, the serverless means this is the perfect scaling, auto-scaling. On demand, it starts and it stops immediately. And with Fargate, orchestrators, Rancher, or Kubernetes, it is impossible because you will constantly have to know to start and stop the pods. No one does that. So if you don't do this, it's waste of money and, of course, CO2. Cool? Permissions. So we got this. This was a simplistic example. I told you it is the permissions are better and the resources are provisioned with the code. So I would like to show you this as well. And who is next in my session? You? Raphael. You are the next one. Who is the next one? No one. You. So you have to stop me. So exactly. Not that I'm talking and you cannot explain virtual threads. It would be terrible. I already mentioned them. So very good with the speaker is here. So you believe me, so this is 5 milliseconds. This is already fast. Usually if you hit the database, it will be less than that. So if you hit relational database, it depends on your queries. If you go to DynamoDB, it will be maybe 10 milliseconds longer. DynamoDB is incredibly fast. If you will go to S3, S3 latency is slower than DynamoDB. It is 30 milliseconds to 50 milliseconds in Frankfurt, what I measured. So what it means on the heavy load, for instance, DynamoDB could be cheaper than S3. Okay? Questions?
That means when you add the database connection, even though it starts up the whole database connection, it's still only 10 milliseconds per time.
Yeah, because in DynamoDB there's no connection.
Okay. And with relational database?
With relational database, there is a connection. And with the relational database connection, we have one problem. What is the problem? Connection pool. If you migrate your on-premise application to the cloud, you cannot launch 5 connections per Lambda. You have 1,000 Lambdas, 5,000 connections. So what you can do in enterprise projects, just start with 1. This works perfectly. Because in a Lambda, there can be only 1 process, 1 Lambda, 1 connection to database. If you have, you know, and then you can restrict in amount of Lambdas to 50, and this is almost like the connection pool. If you would like to have still Postgres, for say, I really have to have it because of migration, whatever, then you can install so-called RDS proxy. RDS proxy is like a middleware which multiplexes the connections. But this is what I try to avoid because of additional effort. I have to, you know, provision this, care about this, TLS certificates. I hate that. So.
But how much overhead for just connecting to the database each Lambda startup?
The connection is alive, and if it starts, I mean, for Postgres, I didn't measure that, but for Postgres, what I know is that the prepared statements, this is what we measured, they almost don't matter anymore. It is very efficient, so to establish the connection. So the networking is very fast, but the connection to a database, I have no idea how much overhead it is. I mean in milliseconds, but it is, my guess would be under 50 milliseconds. This would be my guess, because there's actually just a socket to a database and nothing, but I didn't measure that. But it should be very fast. I had already, with a database expert, a discussion regarding prepared statement, and we measured, and the interesting part was that the prepared statements are not always faster than usual statements, which really surprised me, because at the beginning, I know I measured a lot at the beginning of Java, and prepared statements were pre-compiled, and the usual statement not, and it turned out in Postgres, it always pre-compiles everything, so it is hard to tell. So this is why I struggle to answer, because, yeah. Yes. If you don't like to migrate it, all ORM, forget ORM, everything ORM, ditch completely ORM, rethink the persistence. Or if you would like to go to the cloud, then there's a project called Aurora. It is Postgres compatible, so it scales up and down, but it's relational database and it doesn't solve the problem with connections. But you can absolutely go to Postgres. So what I'm telling you right now, what I will do if I will start. If you have migration project, you cannot just remove 50 tables and say now you don't have the time. I understand, but if you start fresh in the cloud, I wouldn't use Postgres. This is the message. Okay. I would not. Relational database. Yes, if they are simpler to use. Not. Yeah. And what I do, I go, for instance, to AWS, if the project is important. I look for so-called tier 0 resources. Tier 0 are essential for the cloud. This is S3 and DynamoDB. It means if S3 or DynamoDB stops, the entire cloud stops. And there are other resources which are not tier 0. They are not as well integrated. For instance, the OpenSearch is not as great as Elasticsearch, right? Or there is DocumentDB. It is less capable than the MongoDB. So you have to be careful. But the native Cosmos DB is okay, S3 is okay. So the native proprietary technology is good. I will be more careful with technologies which were adapted afterwards. Okay? So usually I either pick DynamoDB or S3 or Postgres, nothing else. So that's what you do. Aurora V2, S3 or DynamoDB. They are the choices so far, nothing else. And for instance, Kafka, I try to have it Kafka and I will pick Kinesis instead, right? So this but if I invested already in Kafka streams in KSQLDB, I cannot use Kinesis, then we have to use managed Kafka. So this is not as simple, but if I would start in the cloud, I will use, for instance, DynamoDB with DynamoDB streams and Kinesis and not Postgres, Debezium, and Kafka. Because I don't have to operate it. Someone said to me, I'm against open source. Like, no, this is just, no, if I go to the cloud, I would like to use it. You cannot go to the cloud and don't use it at all. So I will stay on premise. It's also not a problem, right? I don't have a problem with on premise. I really like it. But I don't like to go to cloud and make everything complicated without any advantage. So, workspace. Now go to Lambda, DynamoDB. Right. Full screen and start with CDK. Permissions. So this is everything is in one file. Usually it is not in one file. In this case, it's one file to show you how it, because it's better for the overview, for the presentation. So this table is a DynamoDB table. And I set it up, and you see here this is pay per request. It means I'm paying per request. I could also provision upfront, which is 20% cheaper, but I have to pay all the time. My advice is start with it, then you see how it behaves, and then you buy afterwards. And now comes the secret trick. If you have secret load, provision, you would say not pay per request, sondern provision 1000 WCUs. This is a write capacity unit. And then Amazon will parallelize the entire database for you, and then switch back per request, and you get the best experience, and you pay nothing for it. So this is the secret hack, but for enterprise project, it doesn't matter. They want access in 10K transactions per second, as I already said. This is just, so. Pay per request means this thing costs you nothing, and we have a database with partition key. I kept the sort key and a table name. Okay? So it means there's no schema. But watch this. The cool story is I create my lambda, which is Quarkus, and what I'm saying here, only this lambda is able to grant and read to this table. So I have per lambda permissions, which are really, really fine-grained. They are hard-coded. Okay? This is impossible with Postgres, or hardly achievable. It means if I use the proprietary resource in the cloud, I can do the same as S3, Kinesis. I can have, my Quarkus and decide which lambdas the process Quarkus is able to access. And I don't know whether you did something with roles and permissions. You will have to create the roles, create the permissions. With this line of code, the entire permission is created for you by AWS. That's the cool story. So there is no discussion, because we say, okay, if AWS runs the cloud and I have the provisioning from AWS and it creates the role for me, it is at least okay. Okay? So, and this is read and write, because this is CRUD, but I could also say, table, I can say grant, and whatever, full access, read data, grant stream is, for instance, I would say, only this function is able to read the change data capture. Table list streams, write data, they're fine-grained permissions. So the implication is, in my projects, we code the infrastructure completely in Java. You are not allowed to change something in the AWS console. What means is, for security review, it is enough to review the source code, which is pretty cool. No, this is declarative. Declarative. This is declarative, not imperative. Yeah, in the CI/CD pipeline. So we have a code pipeline. It costs 40 euros a month, and this runs the CDK over and over again. And this is declarative, not imperative. So you can run it several times, and it will find out the change set, ask you whether you should apply. This is why this don't ask, but because I just do it, right? And then it applies the changes. It's like Kubernetes, declarative, not imperative. Imperative is a CLI. AWS CLI is imperative. This is declarative. Very good. Thank you. Any other questions? No dependencies. AWS. One dependency, because on Azure we use Bicep. This is the Azure language. Questions? So what we talked yesterday, we can package this as a jar, push to, so not yet. There is so-called L3 construct. I could create right now my BaselOne food service. And such a food service will have a nice DNS name. It would be like, sushi.markthalle.ch, right? Every such a food factory will get their own microservice. And because I would like to make it secure, I will give them a table, ordering service or whatever. So what I could create, what we do in larger projects, we create a Java class, let's say a food service, build a pattern. Food service with credit card payment or whatever, and behind the scenes it will create the constructs, and now is the cool story. This construct we push to the corporate nexus. And a new project just pulls the dependency and runs that. So you as developer, you have just to say the configuration, and all the conventions are already set. And you saw already some conventions. As you noticed, the name of the Lambda was the name of the log of the folder where the logs were stored, for instance. Right? We apply conventions on secrets, certificates, and so forth. So it's always the same scheme. Okay. About the source code. How much time do we have, Kai? Oh, you are exact. So his presentation will be better. You will see, very organized. So I have to be faster because Kai is brutal. Say, hey, now it's my time. Let's see, Lambda. So, this is the DynamoDB client. It is static, and there is a trick. If you are using the snap start configuration, you should access something, get metadata at startup phase. And then it freezes the entire AWS SDK in the memory image and starts even faster. Okay, someone asked me about the connection. So this is the configuration. As you can see, we use static system locker from Java-Lang, no dependencies. And this is the entire CRUD with DynamoDB. Of course, completely depending on AWS. DynamoDB is AWS. I don't even try to abstract. Now, someone asked me about migrations. If you do DynamoDB right or NoSQL right is great, but it's completely different to what we do with relational databases. I wouldn't even attempt to use the same idea to apply relational ideas to DynamoDB. So no mappers, nothing. How this works is called single table design. Single table design. And the entire trick is that the primary key comprises two parts. Partition key, which is very important, and sort key, which is not that important, but both keys are unique. Primary key is not unique. What it means is, if, let's say, you have a unique number, registration number at the conference. Now this is not good example. The BaselOne, let's say, 2023, right? Or Basel, the conferences, all conferences in Switzerland. This will be maybe better. So if you go to BaselOne, you will get all the BaselOne conferences which happened. This will be the primary key, the partition key. And the sort key is, how to call it, partitioned. So you have something like attendee hash, speaker hash, food hash, payment hash. What means is, how you work with such a thing, and this has nothing with DynamoDB. You can do the same with MongoDB, with, I don't know, with all NoSQL databases. You create a query like, give me attendees for 2023 conference. It will look like partition key BaselOne 2023 and starts with attendee hash. And then you get back all the rows of type attendee. So it means in DynamoDB, you have one big table per microservice, and every row can be different. And what you can do with it, you can load the one-to-n relation in one hit. And this is why it's so fast and also cheap. So the joins are condensed in one table. It's a little bit hard to explain, but if you do this, it's great. But you cannot just model, you cannot just model relational databases and create multiple DynamoDB tables. It will be terrible. Then don't do it. Then go with Postgres. If you do DynamoDB then the right way, and the right way is single table design, is completely different to Postgres. But I have now the experience. It's an old project, Whitefly, with 50 tables. They are migrating to DynamoDB, and the database people like it because it's a clear concept. It's not a mess. It is different. And what you get, linear scaling. Actually, the cool story is by DynamoDB, the more load you generate, the faster it gets because it caches more and more data for you. Okay. 3 minutes? Oh. Any questions? Now I'm thinking what you can migrate. The question is it worth, right? You have many tables and no one knows what's going on. This is, but limitation, I don't think there's any limitation. The entire Amazon runs like this. So, I mean, the most fresh projects, not in Java land, are using this, right? So I would say, why I'm doing this? Because I don't like to fiddle with infrastructure in the cloud. This is the only reason. If Postgres would be like DynamoDB, I wouldn't have to care about anything. It would be as cheap as this. I would never use DynamoDB. This is the truth. But if you take a look what it takes to operate a relational database in the clouds, and you compare not in clouds, in the cloud, and you compare it with that, so I would rather write such a Java code than operate the Postgres. you don't have to care about this. Forget, you do it once and forget about it. It runs in the cloud. And if it stops, the entire cloud will probably stop because this is tier 0 service. But you constantly have to care about your Postgres database. Cool. Then I'm done. If you like, I have here stickers. If who asks question gets even, a pencil here. You have to take it because it is heavy, and I have to go to Geekon right now. So thank you a lot. I hope it was better than slides. So we covered, I hope, whatever I claimed in the keynote, I showed you in the source code. If not, I could show you, but you didn't ask the questions. So whatever I could imagine, I showed you. But next time, ask more questions. I have more code on my machine. And what you saw right now, I do it all the time in all my projects. And why? Because if you go to management and show how cheap it can get, there are no arguments against. And money talks. The first time in Java history, we can prove that we can save money. It was impossible before, actually. Right? So we can go with an Excel to management and say, look, if you do this, we save this amount of money. Done. Cool? Now virtual threads.